So what I want to do is I want to go through sort of the whole thought process about approaching these proofs. Okay, so starting with this example here. Okay, if you label what you have from your givens, so if I know I have QT is equal to TS, and I know that RQ is equal to SP. So if I label what I have on my diagram, and then go to my proof and find where those statements are. I see they're right here. They're generally going to be at the very first statement, and identify that correct reason as givens. Okay, next, if I look at the statements that are provided here, what I want to do is I can look to see what would be the likely scenario for introducing that statement. So here I have RT equals RQ plus QT. Is this set up in the form of segment addition? Is it structured like a segment addition relationship? One thing is equal to the sum of two things. Whole is equal to the sum of the parts. Yeah, it's structured that way. So let's test and see, is this a segment addition? So is it true that RT is made up of RQ plus QT? Yes. So that means it's segment addition. You can go ahead and mark that. If it's not, if it's a different relationship, then more than likely what you're either doing is replacing like parts of similar types of equations, meaning substitution, or there's a potential that you're subtracting a value to leave one thing alone by itself. Okay, if we look at the next statement, TP equals TS plus SP, does that have the structure of segment addition? One thing equals the sum of two things? Yes, that's the structure. So if I look and see, is it true that TP, this whole thing, is equal to TS plus SP? Is that segment addition? Yes. Okay, now when I look at the next statement, I have RQ plus QT is equal to SP plus TS. Is that the structure of segment addition? The sum of two things equals the sum of two things? No. Okay, the only way that that could exist as a statement is if we took two things and added them together, meaning if we took like RQ is equal to SP and added QT on one side and TS on the other side, that's one potential. Okay, or if we had these two statements somewhere earlier in our proof, so do we see RQ plus QT somewhere earlier? Yes. SP plus TS, it's in a different order, but yes. Okay, are those set equal to the exact same thing? No. Okay, so that's not transitive property, but again, that's kind of where your mind should go. Test for transitive property first. Okay, and so since that's not, let's see if we can combine these. So do I have two statements that I can add together to get this statement? So do I have RQ is equal to SP? Yes. If I add QT to one side of my equation in order to balance the equation, I have to add its equivalent. So either QT or what it's equivalent to, TS to the other side. Is that what happened to create this statement for? Yeah, I started with this equation. I added QT to one side, TS to the other side. If I add equals to equals, the sums are equal is which property? Okay, that's the example of addition property. Okay, and then once I get this statement set up, I go back and I see RT equals TP. Again, there's a couple different ways that that could happen. So first I need to look back again and see, do I have RT and TP somewhere earlier in my proof? Here's RT, here's TP. Are they set equal to the exact same thing? They're equivalent things, right? We see that they're equivalent by step 4, but are they exactly the same? They're not. They're different things, right? So this, again, is not transitive property. Okay? If they were the exact same things, it would be transitive. But since they're not, what we can now do is look for substitution. If I took this statement from step 4, what can I replace RQ plus QT with? Its equivalent is RT. What can I replace SP plus TS with? Its equivalent is TP. So I just replaced two things with their equivalents. Replacing is substitution only. Okay, so those would be the steps for completing that proof.